So, good evening. Now, today we are going to discuss about the topic Unit 3, that is peripheral interfacing. So, these Unit 3 generally covers the interfacing concept. So, in Unit 1, we are discuss about what introduction to microprocessor, 8-bit and 16-bit data. In Unit 2, we are discuss about the what are the system bus structure are available for configuring the various application microprocessor. In unit 3, this is the main thing, we are going to interface each and every concept. So first one is a memory interfacing and IO interfacing. There are two type of interfacing agent is available. In memory interfacing, only the memory can able to fetch the data. In IO interfacing, input and output both are able to fetch the data. So these are the difference between the memory and input output. And there are two type of interface communications are available. One is a serial communication, other one is a parallel communication. So these are the various type of interfacing communication in unit 3. And we are having also the A bar D and D bar A interface, that is digital to analog interface and analog to digital interface. After that, we are going to study about the controller, the keyboard and display controller, DMA, that is direct memory access controller. After that, we are everything comes under the case study, that is application oriented, traffic light control, that is very important nowadays in microprocessing unit, and LED display, that is light emitting diode, and alarm control. So these are the basic application how this interfacing works in various devices. Okay, shall we discuss about the this concept? Now I'm going to discuss about the architecture of 8051. So this unit basically covers the architecture. What are the architectures are available in 8051? First one is an 8-bit CPU with a register A that has an accumulator and B register. After that, it has a program counter already studied in the microprocessing unit. Microprocessor contains the register, counter, and various devices. So program counter and data pointer, then memory address, data address. After that, it has a input output pins. Mainly consists of a 4 8-bit ports. So these interfacing unit, we have needed a port. So port consists of a 4 types, that is port 0, port 1, port 2 and port 3. So it has a 32 bits of input output pins, which each pins consists a 8-bit port. So 32 denotes the number of IO pins and each pins has the 8-bit ports. Okay, and also it has a counter, that is two type of counter, that is T0 and T1, and it has a buffering value, that is full duplex and half duplex, and clock oscillator is provided in the signal. So these are basic features of 8051. So these are the architectural diagram already discussed. It consists of various port, that is 4 port, port 0, port 1, port 2 and port 3, and it has a register, and in left side we have a timing and control unit. In each timing and control unit we have a reset option and set option and enable option. So these are the three important concepts. After that, in right hand side we have a port, and here we are having the program counter, buffer, register and data pointer. So these are the concept of the architectural unit. We are supply, the supply we are already know, it has a 5-volt input supply. That supply is given to the microcontroller, then it works instead of using these types of architecture. So what is a B register? A B register denotes the multiply and divide the operation. That is the function of a B register. It either has a two inputs, the two inputs, that is A and B, or any data. The data are stored in the multiple value or divide value. What is a stack pointer? A stack pointer is a 8-bit register that keeps the memory tracking, how many memory are available in the processor. For example, it has a 1 KB of memory or 1 MB of memory. So it is able to track the memory space. That is main function of a stack pointer. Then it is also increment or decrement the operational microprocessing unit. So the stack pointer is automatically whether it increases the value or decreases the value based on the instruction we are loaded in the microcontroller. So these are the stack pointer operation. I already discussed about the program counter. What is this? It just holds the data until the next instruction will be fetched. So this is the program counter. And data pointer is nothing but it's able to fetch any data from the space, that is memory space. In memory space, if any data is there, it is able to fetch and given to the other data point. So it has also a two 8-bit register, DPH and DPL. The DPH denotes the data pointer high value and DPL denotes the low value. And program status word, what it does, it able to find out the current status of the ALU unit. So for example, if the memory organization has many values, it able to track the correct value and store that in a various memory location. That is the main idea of a program status word. So here they are applying the logic, that is logic 1 or logic 0. So based on the logical we are applying it, find out the current status of the ALU. So these are the flags. So totally we have a 6 flag. So what is a flag? Flag denotes the user information. It carries a data or anything else. So this first one is a carry flag. Other one is an auxiliary carry flag. That's a user flag. Then the select register bank RS1. Then select register bank 0. Overflow flag and parity flag. Parity denotes the it has a two devices, either even parity or R parity. Able to check the numbers. So these are the types of flags are available. Next we are going to about the timer or counter. So timer or counter denotes, I already defined, T0 and T1. So either high state or low state based on the information we are given. Here we have the two mode of control register. One is a TMOD, other one is a TCON. TCON denotes the timer control register. T mode denotes the timer mode register. So these are the two type of timer and control devices used in the microcontrolling unit. An oscillator and clock. Oscillator and clock have an internal operation, that is it is also a pin that has some crystal frequency used for an oscillating the main values. The crystal frequency is based on the clock value. How the clock signals we are provided. Maximum we are having the 3 MHz of clock signal that able to store in the microcontroller. So memory organization. What are the memory organizations are currently available? First one is a program memory, data memory, and other special function register that comes under the various type of register. So these are the basic ideas about the unit number 3. So I repeat. First we are discussing about the architecture. Again we are going to study about the memory organization, and then what are the timer and counter we are discussed, and what is the architecture performed in each part we are discussed. So thank you.